Good morning, ladies and gentlemen. Today we're going to discuss how to simplify radicals. This is Chapter 12, Section 4. We are going to use a modified factoring tree for this. Now, even though we know that the square root of 36 is 6, we can kind of look at the process that we're going to use for the harder problems, and maybe it'll make a little bit more sense for you. We're going to use a modified factoring tree for this. We're going to take 36 and we're going to look for perfect squares in the 36. Now 36 has a 4 that goes into it. 36 is 4 times 9 and 4 is a perfect square. We are allowed to rewrite the square root of 36 as the square root of 4 times 9. If we do order of operations, 4 times 9 is 36. It just turns back into the original problem. Now we are allowed to break that up. We can actually give the 4 and the 9 its own radical sign. Now we will take the square root. Square root of 4 is 2. The square root of 9 is 3. And we will multiply those things together. 2 times 3 is 6. This, which I'll outline in orange, would actually be a way you could prove that the square root of 36 is 6. We're going to have to simplify some radicals that do not have perfect squares in there, like radical 18. Radical 18, you can't take the square root of it without a calculator because it is not a perfect square. However, 18 has a 9 that goes into it. 18 is 9 times 2. If we were doing the prime factorization, we'd continue, but we're just trying to simplify the radicals, so we're going to stop. I'm going to rewrite the square root of 18 as the square root of 2 times 9. I can then write that as radical 9, or radical 2, I guess, 2's in front. Radical 2 times radical 9, and now take the square root. The square root of 9 is 3. 3 radical 2 is the simplified version of radical 18. On the calculator, they'll give you the same decimal equivalent. They're both irrational numbers, and they are the same irrational number. Number 2. 50. We are going to try to find a perfect square that goes into 50. Perfect squares include 4, 9, 16, 25, 36, 49. 25 goes into 50. 25 times 2 is 50, as a matter of fact. So we'll rewrite this as 4 times the square root of 25 times 2. We'll give each term underneath the radical its own radical sign. Square root of 25 is 5. And to finish, 4 times 5 is 20. So 20 radical 2 is the simplified version of 4 radical 50. Let's switch colors here just for clarity. For number 3, 48. There's good choices and bad choices here. 48 is kind of a complicated problem. Ultimately, the best choice would be 16 and 3. We can do 1/2 radical 16 times 3, which is 1/2 radical 16, radical 3. And the square root of 16 is 4. Before you finish, what's half of 4? That's 2. 2 radical 3 would be the simplified version of 1/2 radical 48. That's the quickest way. You'll notice it's the exact same length as problem 2. In blue, I'll show you the longer way. Maybe someone doesn't really test and work that hard to figure out what goes into 48, the largest perfect square possible. So they use 4 times 12. And you have 1/2 radical 4 times 12, which is 1/2 radical 4 radical 12. And it's all kind of going the same way. It looks pretty good. You end up getting 1 radical 12. And you think you're done. The problem is radical 12 can be simplified even further. So 12 is 4 times 3. So this becomes radical 4 times 3, radical 4 times radical 3, or 2 radical 3. So you get the same answer. The problem in blue took 2 steps to do. The problem in orange, 1. Just look at the lengths. Try to find the biggest perfect square that goes into your number. It will make the problem considerably shorter. That's problem 3. Let's take a look at number 4. Negative 4y squared. Now, if we take 4y squared, perfect square that goes up 4y squared, 4y squared is actually a perfect square. It's radical, it's 4y squared times 1. So we can actually write this as negative, and then just take the square root. What's the square root of 4? What's the square root of y squared? and it's done. This one doesn't require any simplifying. Just take the square root. We did that yesterday on our homework assignment in class on that third page. So we had some experience doing that yesterday. Okay, let's take a look here. We can do this in three parts. When you get a little bit better, you kind of do this all together. 75 is 25 times 3. Okay, x squared is a perfect square. So we're just going to say, I guess I'm going to leave that off of here. Y cubed is y squared times y. And z to the 7th is z to the 6th times z. All right. So we're going to break this into two parts. Everything we can take the square root of, 25, x squared, y squared, and z to the 6th. We can take the square root of that whole thing. My second radical will be the stuff I can't. 3, y, and z. So that 3, that y, and that z that were left over, those are going to go under the I can't take the square root of you radical sign. The square root of 25 is 5. The square root of x squared is x. The square root of y squared is y. And remember, we take the square root of z to the 6th by dividing z by 2. So there's your square root. All of the stuff I can't take the square root of stays underneath the I can't take the square root of u radical sign. And that would be the correct answer. So it gets a little bit different when you're dealing with variables. Not harder, just different. All right, so let's see here. 8 is 4 times 2. So I got my 3 out in front. I can take the square root of 4, and I can take the square root of x squared. Didn't need that radical to be so big. I can't take the square root of 2. So the square root of 4x squared is 2x. That radical 2 comes down. 6x radical 2 would be the correct answer. Hi, Mr. Leffler's coming in and mucking up things. All right, we chased Mr. Leffler out of here. Let's get back to work. We have our 2 here, so let's see. 27 is 9 times 3, 9, 3. B to the 5th, I can take b to the 4th. I can take the square root of that. I can't take the square root of b. And that c, of course, I can't take the square root of that either. So stuff I can take the square root of. I can take the square root of 9, b to the 4th. I cannot take the square root of 3bc. So I do it. Square root of 9 is 3. Square root of b to the 4th is b squared. And then that 3bc is hanging out there. 2 times 3 is 6. Finish it off. Make sure it looks nice. Good. All right. 18. Radical 175. Well, $1.75 is made up of a bunch of quarters. So how many quarters would that be? Let's see, 4 quarters to $1.75. How about 25 times 7? So this becomes radical 25 times radical 7. That is 5 radical 7. And done. Look how quickly they can be done if you can find that perfect square that goes in. And there is a step that's being skipped here. If you look at the previous page, you notice that we had written this as 25 times 7 underneath the radical sign. And that would be all the work with nothing skipped. Okay? Let's see here. 500. Ooh, 500. 500. You might want to go with 25, but remember, if we do the biggest perfect square that goes in, we're going to have the easiest time. M to the 9th. Well, remember, I can take the square root of any even exponent. So m to the 8th, I can. M is going to be left over. And finally, the n. I can take the square root of n to the 24th power, because it's even, but that's going to leave me with an n left over. 2 is still out in front. The stuff I can take the square root of, I can take the square root of 100, m to the 8th, n to the 24th. I cannot take the square root of 5, m, n, all the leftovers. So I do it. Square root of 100 is 10, m to the 8th is m to the 4th, n to the 24th is n to the 12th. The 5mn is stuck in limbo there because we cannot take the square root of it. Look at me, I almost boxed that up. What did I forget to do? Take a look. Final answer, 20m to the 4th, n to the 12th, radical 5mn. That should be a 12 here, looking a little bit messy. So once again, basically we are breaking the number up into two radical signs. The first one will include things we can take the square root of. The second one will be things we cannot take the square root of. If I multiply them together, I'm going to get the original problem. Nothing's going away, nothing's disappearing. Our last problem, 45 is 9 times 5. X to the 10, I can take the square root of that, so I won't worry about breaking it up. Y to the 7th is y to the 6th times y. So I got my 1/3, 9, x to the 10, y to the 6th. What I cannot take the square root of, I have that 5 and that y here, 5y. So I got 1/3 times the square root of 9 is 3, the square root of x to the 10, the square root of y to the 6th, and then the 5y is hanging out. 1/3 of 3 is 1. These cancel each other out. You get a 1 here. So x to the 5th, y to the 3rd, radical 5y. All right. So hopefully there wasn't too many disruptions here during this lesson. We had some people dropping in, and I'm a little sloppy. So I apologize for that. I look forward to seeing you tomorrow. Bring your textbook. We're going to work on page 486, 3 through 30 all. Have a wonderful evening.